So in my first example, I have 5p plus 1 equals 36. Again, 5p means 5 times p. And the value that I'm given is p equals 7. So the question is asking, if I substitute 7 for p, will this equation that I'm given be true or false? So let's find out. First, I'm going to rewrite this as 5 times p plus 1 equals 36. Next, I'm going to substitute and plug in 7 for p. So I have 5 times 7 plus 1 equals 36. Now I'm going to work on the left side of the equation, and I'm going to use the order of operations. So I have a multiplication and I have an addition. I have to do my multiplication first. So I have 5 times 7, that's 35, plus 1 equals 36. And I'm left with an addition. 35 plus 1 is 36. 36 equals 36 is a true statement, so the answer is yes. 7 is a solution to the equation.
Today we're going to solve single variable algebraic equations. Now this is an example of a single variable algebraic equation. X is the variable. The objective is always the same with this kind of equation. You want to get the variable by itself on one side of the equation. Now, an equation is like a scale that's in balance, and it's your job to keep it in balance. So in this case, we're adding something to x, and that's 17. So what we're going to do is subtract 17 from both sides of the equation. So x plus 17 minus 17 just leaves us with x. And 20 minus 17 gives us 3. So x equals 3. This is pretty much how you solve these. It's a step-by-step process. That's how you solve single variable algebraic equations.
We're going to begin this example by writing the equation. Our problem is a number n squared plus 11 is 36. N squared plus 11 equals 36. To balance this equation, we'll begin by subtracting 11 from each side of the equal sign. That leaves us with n squared on the left side of the equals, because plus 11 minus 11 cancels each other out, equals 36 minus 11 is 25. From here we take the square root of each side, which leaves us with n on the left side of the equals, and the square root of 25 is 5.
Today we're continuing our discussion of solving single variable algebraic equations. This is an example of a single variable algebraic equation. The objective is always the same: get the variable by itself on one side. And anything you do to one side, you have to do to the other. Now in this case, we're multiplying the variable x by the number 4. Since we're doing multiplication, we'll do the complementary operation, which is division. So if we divide both sides of this equation by 4, 4 divided by 4 is just 1, so we just are left with an x. 28 divided by 4 is 7, so we're left with x equals 7. That's how you solve this type of single variable algebraic equation. Today we're going to continue our discussion of solving single variable algebraic equations. This is an example of one here. It might look a little more complicated than ones you've seen before, but let's just try to solve it and see how it goes. Remember, the objective's always the same. You want to get the variable, which is x, by itself on one side of the equation. And the equation is balanced, so whatever you do to one side, you have to do to the other. Now, in this case, we won't worry about this 2 right away. Let's deal with this 3 that we're adding to the x term. We'll get rid of it by subtracting 3 from both sides of the equation. So 2x plus 3 minus 3 just leaves us 2x. And 11 minus 3 leaves us 8. Now this looks pretty good, but we've got a 2 in front of the x, and we'd really rather just have a 1 in front of the x. So since we're multiplying x by 2, we're going to divide both sides of this equation by 2. 2x over 2 just leaves us with an x, and 8 over 2 gives us 4. So the answer to our problem is x equals 4. And that's it. That's how you solve single variable algebraic equations. It's a step-by-step process, so give it a try.